Are you aiming for a role as an AI/ML engineer, data scientist, or AI specialist? One topic you'll likely encounter in interviews is fine-tuning. Let's break it down so you're fully prepared. AI models like GPT are very powerful, but they can struggle with specific tasks. For example, a general model may not understand legal documents, medical terms, or customer service needs very well. And this can lead to mistakes or ineffective results in real life situations. So, how do we fix it? That's where fine tuning comes in. Fine tuning adjusts a general AI model to work better for a specific task or industry. This helps the AI be more accurate and reliable for those tasks. And in this video, we will explain fine tuning, how it works, how it's different from transfer learning, and how it helps in real world areas like healthcare, finance, and customer service. This video is just a glimpse of what we dive into in our live AI/ML program. And if you're serious about taking the next step in your career, learning the same 3-step framework that's helped people like Debashish, Arun, and Roshan land high-paying jobs and top certifications could be your game changer. And if you're ready to unlock your potential and make real progress, join our upcoming free masterclass on how to land a high-paying job in AI/ML, GenAI, data science, and Agentic AI. You can register through the link given in the description below. So let's get started.
Fine-tuning. Okay. So what is this? So you created a foundation model. So what is the foundation model? The first raw model that you got by training on unstructured data. That is a foundation model. But the foundation models will still struggle to do some specific tasks because most of the foundation models are trained for the next word generation task or guessing the masked word. So that's how you train the models. Encoder model are trained by masking a word in a given line, and the decoder models are trained by asking the model to predict the next word. So next word prediction or masked language modeling, MLM. Okay, these are the two specific tasks which mostly people use to generate the foundation models. Okay, so foundation models are trained on unstructured data, not specific user instruction-based data. Okay. So what I was saying is unstructured data, that entire internet of unstructured data, Wikipedia, Common Crawl, everything. Okay. So you create a foundation model with whatever hundreds of billion parameters, doesn't matter. That is how GPT-1, GPT-2, GPT-3, these were all foundation models. So they were having some generation capabilities, no doubt, but they did not have capability to follow users' instructions. So for example, what is the capital of France? It will simply say Paris. It will not generate the answer in a natural language. The capital of Paris, France is Paris, or something like that. Or rewrite this email in a more polite, compelling way. I mean, that kind of instruction following was not there. Okay. So that is where people thought, no, this kind of a foundation model is not very helpful because it's still useless for the model, for the end user. Okay. You need to fine tune it for specific tasks because the users will be looking for these kind of specific tasks. Not every time, tell me a joke. Now, tell me a joke is a standard case of a language generation without any boundaries. So it can just create any blabberish joke and tell you, okay? Or give me a poem about so-and-so topic. Write down an essay about so-and-so topic. So these are very generic prompts. So you are just leaving the model to explore its own capabilities, okay? But now these kind of specific tasks could not be handled by your foundation models. Okay. And that is where people recognize that, yes, there is a gap. Okay. Not only to follow specific tasks, but also domain specific again. So you want the model to give you an output in a legal language or medical language. Okay. Now, since the model has not been trained on domain specific data, it was just trained on generic internet data. Okay. So these kind of, use cases emerged. Okay. So now you take a foundation model and train on task specific data set. So what do you mean by task specific data set? So think about translation. So I've got a data set of, let's say, 100,000 rows. Each row you have a sentence in English and its corresponding translation in French. Sentence in English, corresponding translation in French. English, French, English, French, English, French, English, French. So that English words goes as the input X and the outputs expected is your Y. X comma Y, supervised learning. So what you are doing is a supervised training of a foundation model. For which task? Translation task. So this is called as SFT, supervised fine tuning. Okay. Classification. Okay. Let's say you want your model to identify the sentiment. Fine. This is a product review, sentiment positive. Product review, sentiment negative. Product review, sentiment neutral. So you create a data set and then you retrain your foundation model on this classification data set. How do you do that? You attach a classification head, basically. You don't change the architecture of the original model. That is just too complex. So you add a couple of additional layers. I'm just giving a very high level idea. Okay. So this is what we call as classification head. And then you train on that classification head. Okay. So basically you are adapting a foundation model for a specific task by retraining it on some additional data. That is the most important word. So two important words are there. Number one, you are changing the task. You are assigning a new task to the model during training. See, originally the model was trained for generating the next token or guessing the probability of the missing token or masked token. That was the original task on which the foundation model was trained. Now your task is to do classification, summarization, question answering, translation. These are the tasks. And based on these tasks, you have prepared the data sets also. So now when you are adapting, listen to me carefully, when you are adapting a foundation model to a new task, when you are adapting a foundation model to a new task, that is called as fine tuning. Okay. Transfer learning means there is also a very similar familiar word. I mean, people who are coming from machine learning, deep learning background might already be knowing transfer learning. So in transfer learning, we don't change the task. A model which has been trained on a specific task, okay, you can transfer that learning to similar task, but a different data set. Okay, so think about your ResNet model, ResNet V2 model or VGG16 model, ResNet V2 50, let's say, model. Okay. So this is an image classification model, fantastic image classification model. It can classify images, but this model was trained, this ResNet 50 model was trained on ImageNet dataset. ImageNet dataset contains 14 million images across 10,000 classes. But now my domain contains 5 specific classes, 5 specific types of images. Let's say my dataset, my custom domain specific dataset or my industry dataset contains only 5 classes instead of 10,000. Okay, only 5 classes, let's say 5 types of images. Think about that way. And this model has never seen any of such images in its previous training. Once again, I repeat, this model, although it has been trained on 14-15 million images, which are hand annotated, hand labeled, okay, but it has never seen my company's data because that is proprietary. I have never made it public. Okay. So now my company has generated 10,000 such images. Okay. And it has these models have never seen such data. So it cannot do a prediction, as simple as that. So what I'm doing is taking a classification model and adapting to my own data set. That is called as transfer learning because you are transferring the learning from a different data set to your own data set. You are not changing the model architecture, number one. You are not changing the model architecture, number one. And number two, you are not even changing the task. The model was originally trained for a classification task, but on a different data set. And the model is now being again trained for a classification task, but on a domain specific data. So as long as the task remains the same, we use the word transfer learning. But now what am I saying here? The task has changed because the original model, the foundation models were trained on masked language modeling, MLM, or next token prediction, depending on whether it was an encoder or a decoder model. Okay. Since the task has changed, it is no longer transfer learning. Okay, it is fine tuning. So that is the most technical difference between transfer learning and fine tuning. The change of task calls for fine tuning. As simple as that. Second, we're also changing the data set. Okay, specific to the task. Anyway, it was already there in the previous case also. Okay, so that's how. So your reasons or motivations to do fine tuning. So one reason is to instruct the model to follow specific tasks or to perform specific tasks. This will also called as a specific type of fine tuning is also called as instruction tuning. A specific type of fine tuning is also called as instruction tuning, where you train the model to follow the user's instructions carefully, strictly. There's a concept called as instruction tuning, which is a subdomain of fine tuning. Ultimately, it's a specific type of fine tuning where you instruct a foundation model or a previously fine-tuned model also you can take. So multiple fine tunings can be done. So you can take a foundation model, create a fine-tuned model, and this fine-tuned model can be further fine-tuned or instruction tuned. That also can be done. So, I mean, there's no big deal that people do multiple levels of fine tuning also. Okay, that's very much popular. Okay, so fine tuning back to back can also be done. Okay? That is also, I mean, quite justified. I mean, logical. Okay, because the previous fine tuning was for a different reason or for a different intention. So I am just making it even better, or I am just making it even more specific. That's it. So adapting the model to a specific domain data, that can also be a very good reason to do fine tuning. Think about the Bloomberg GPT. So they took the GPT model, GPT 3, 3.5, I don't remember. Okay. And then they fine tuned it. The Bloomberg already had access to all the companies' information across the globe. Okay. And they wanted to create a model which is aware of the financial terms, how to read the balance sheets, how to read the SEC filings, 101, 10K filings, everything, okay? Or the ROC filings in India, uh, the registrar of companies ROC filings, or SEBI filings done by these companies periodically, okay? For all sort of financial analysis. So that's what, and they figured out that this Bloomberg GPT literally outperformed similarly sized models on financial NLP tasks. Financial NLP tasks. So you are asking a question about that financial, so think about the doing a SWOT analysis of a company financially. Okay. Now that's very, very specific task. Okay. Or you want to compare to mutual funds, something like that. I'm just giving some ideas. And that too without sacrificing the performance on the general LLM. So general LLM benchmark was still maintained, plus it gained additional capability of performing on the financial NLP task. That was add-on. I mean, it did not sacrifice the previous capabilities, but this new capability emerged because of fine-tuning. So that's a 50 billion parameter model. Okay. So that's how, and that's again a more than 2-year-old story. Okay. Before that challenge, style fine tuning. So you want the model to write down, or generate answer in specific tone or specific style. So for example, a customer service chatbot has the company tone or company branding, something like that. Okay. It is aware of all the company's products and functionalities of those products, nuances, what previously customers have asked, everything, all the information it has. So now it is a well-trained chatbot. Okay. So now if I ask the question, I get more appropriate answers, more customized answers rather than generic answers. Okay. So it has already known all the company specific data, and it has also seen all the 100,000 chats which previously have occurred. That was also saved by the company, right? Any sensible company would save that data also. So all that was also used to fine tune such a model. So now I have a fine tuned chatbot for my company, let's say. So that's another use case. So these are the three main, reasons for doing fine tuning. Okay. Case study example, take a general LLM, which is good at many tasks, no doubt, fine. Collect the 10,000 product descriptions and then train the model on your company's specific format and product descriptions. And then for any new product, you just use your fine-tuned model. Your fine-tuned model will generate complete product descriptions matching your brand perfectly. You don't have to give very super sophisticated instructions. That's why, so the fine-tuned models are now very easily available. On Hugging Face, there are more than 10,000 fine-tuned models freely available, open source. So that was not there 2 years ago, right? Now we have more than 10,000 fine-tuned models, super fine-tuned models also, easily available. Okay. So that is also a reason prompt engineering is no big deal, because these models have already been, fine-tuned to follow users' prompts. So even if your prompt is a bit naive, your model will still be intelligent enough to figure out what you exactly want and will be able to adapt accordingly, right? So clear use cases, when you want your model to have domain specific knowledge, you can use fine tuning. Also, you can go for RAG, no doubt. So that is where we are getting into. Consistent output format, yes. But for a RAG, answer is no. There is no guarantee you will get the output in a specific format. In the case of a RAG, you might have to do an extensive prompt engineering for that. So this is very complicated and still not guaranteed. Okay. Brand voicing style, yes, that is what we have just now seen. You can use type format prompts. That is easily doable using prompt engineering. General questions, for general question answering, you don't have to have a fine-tuned model. You can still take a base model or a foundation model or any of the out of the box available model. For general question answering, you don't need fine-tuning. If you are asking questions about the current event, just like what happened yesterday's meeting, okay, can you summarize in 10 bullet points? You don't need a fine-tuned model for that. Okay, all you need is a web search tool, give it to any standard LLM as a context, the raw information, and that LLM will give you the responses. So that's what RAG with news sources and so on. So biggest challenge here is this. You still need a high quality training data. So people really spend, or companies really spend a lot of time in curating such a data. Number one. Time and compute extensive, that is what I've already mentioned. Okay, because you are literally again changing the model architecture, original model architecture to some extent. This is very, very critical. I mean, risk of overfitting. When does this happen? When the amount of data that you are providing to the model is small. Then what can happen is your new model, see, these LLMs are already quite heavy models, quite complex models. So if you are not providing enough data for fine tuning, it can actually learn too well on that training data. Listen to me carefully. It can actually learn too well on that training data and forget its previous training data. And that is a concept called as catastrophic failure. You can search Google. What is catastrophic failure in LLMs? Okay. See, these are the nuances. Okay. So if the new information is not huge, okay, then in a desperate attempt to learn this new information, it might forget the previous learned things. Okay. So that is also referred to as catastrophic forgetting. Broadly means during fine-tuning, a model loses much of its original knowledge and abilities also. You thought that fine-tuning is everything, and now you are learning the nuances. Okay. So, and even literally it can perform worse than the previous foundation model. Okay. Yeah. So it can forget even common knowledge. It will start producing any gibberish outputs, nonsensical, repetitive, and fail to follow the instruction altogether. So this is what we call as catastrophic failure. Okay. And this is the biggest reason. Overfitting again. Okay. So same story goes. Okay. Model memorizes the new data set just too well at the cost of generalization. So this overfitting risk is a big risk while fine-tuning models. So you need an expert in deep learning, expert in LLMs, expert in these transformer architectures, expert in fine-tuning techniques like parameter efficient fine-tuning, PEFT, LoRa, QLoRa, and many other things are there. So you literally need a fine-tuning expert who will be able to make sure that these things don't happen. Fine-tuning, what does it mean? So things may not stop at fine-tuning. Let me just give you one last step. So what was the first step? Train a base or a foundation LLM. Adapt it to a specific task, which is your fine-tuning, second step. Third step could be instruction tuning, which is again a type of fine-tuning. Fourth step is what we call as policy alignment. Fourth step is what we normally call as policy alignment. So as a human, I have some policies. I want the model's output to align with those policies. Okay. DeepSeek has a policy that it will not reply any questions related to India-China border conflicts, any sensitive information about China. Model trained in Chinese company is expected to do that, because who has set these restrictions and regulations? The Chinese government, of course. And how did that company who has trained this model make sure that the model is not going to answer any questions about China in a negative way, or any questions about, let's say, in general, any religion or any god in a negative way? So these are human policies, ethics, bias, and all that stuff. So there has to be some sort of a further tuning beyond the tasks. This is what we call as policy alignment. Okay? And that is done by RLHF. There is a concept called as reinforcement learning via human feedback. Okay. So how does that work? I'll give a very simple example. Okay. So think it this way. Yeah. So let's say there is a user query. This is our model. Let's say fine-tuned model. And the fine-tuned model generates, you ask the same question in 3 different ways. So I get 3 different responses. Model is still the same. Ask the same query in 3 different ways, and you get 3 different responses. Ultimately, the query was still the same technically. Then what do you say is, okay, a human interpreter would be there. A human interpreter would be there. So the human will mark, okay, this is a desirable response out of the 3. These 2 are non-desirable. So for one user query, 3 responses generated. This is what even ChatGPT does with you occasionally, if you have noticed. Okay, it gives you 2 set of responses and asks you what a response for the same query. Okay, 2 set of responses. Which response do you prefer? Has anyone seen that before? ChatGPT asking you which response would you prefer? So your response is actually being saved, and you are literally improving the model. Okay, it is so they are not giving this service for free, literally freely every time. Okay, fine. So a human marks that this response is the best. Okay, so now just repeat this process 10,000 times. So 10,000 such questions, 10,000 set of answers, out of which the human will keep on marking this or this or this, whichever is the most appropriate answer or most desirable answer. As a human, let's say, I might be more comfortable with the language used here. Okay, now the language could mean or let's say this used excessively, some particular words were used excessively. So this can easily sound robotic. So that what is the reason I reject. So there could be any reason. There could be multiple reasons for rejecting the other responses. Okay. So literally you are teaching. So now what do you have? At the end, what do you have? At the end, you have 10,000 questions. You have queries and 3 set of answers for each, and a final target. Target is, let's say, 0, 1, 2, I think whatever numbers. Okay, now what is 0, 1, 2? 0, 1, 2 is the index of the responses. So index 0, 1, 2. Okay, so the most desirable answer. This is the most desirable answer. So now you can again do further fine tuning. Okay, So there are concepts called as DPO, direct preference optimization, PPO, policy preference optimization. So DPO, PPO kind of RLHF techniques are there. RLHF techniques are there. You can just take these words into ChatGPT and get the entire story. Okay. So in this, again, we are training the model by kind of a reward model, rewarding. So I will reward the model if it generates. So how do you give that feedback back to the model? Because if the model generates this response, I will reward the model because this was desirable. And I will penalize the model for generating these kind of responses which are not desirable. So for each response, I will either reward the model for a particular response and penalize the model for other responses. So based on this reward and penalty, that is called as reinforcement learning. So entire reinforcement learning works on that concept called as reward and penalty. Okay. So literally you are rewarding the model to generate specific style of outputs. So slowly the model starts realigning towards specific tone of outputs, specific style of outputs. Okay, that is how it learns, okay, this kind of output is not desirable. Okay, so whenever it talked anything about China negatively, the model was heavily penalized during the RLHF stage. And so at the end, after doing that iteration over 10,000 times, the model literally learns that the moment I start speaking anything negatively about China, I'll get heavily penalized. So it doesn't even attempt doing that. So that is the last step, aligning the model towards human policies. Okay. And that is done mostly manually because you need that manual intervention here. Okay. How does the model know on its own which is a desirable response to the end user? Now, model cannot know that. Only the human will be able to mark. And the moment human marks, then it goes back to the training machine where this penalty and reward actually happens later.
So that's a wrap. I hope you now have a clear understanding of how fine-tuning helps make AI models more specialized and accurate. So whether it's improving customer support or making medical predictions, fine-tuning ensures AI delivers the best results. And if you are ready to dive deeper into fine-tuning and other in-demand AI/ML skills, join our free AI/ML GenAI Data Science and Agentic AI Masterclass. It's your chance to learn how to apply these techniques and land top AI jobs. So you can register through the link given in the description below. And if you like this video, don't forget to subscribe for more such videos and definitely check out our previous videos over here.